Most things around us are made by cutting, molding, or assembling materials in factories. But 3D printing works differently. Instead of removing material, it builds objects layer by layer using a digital design. A machine slowly turns plastic, resin, metal, and other materials into real objects. What once sounded like science fiction is now used in homes, schools, hospitals, construction sites, and even space programs. Today, we're exploring how does 3D printing work? From its origins in the 1980s to the way modern printers create everything from toys to artificial body parts, this is the story of one of the most important manufacturing technologies of the modern era. Let's dive in, right here, on History of Simple Things. "3D printing began in the early 1980s when engineers started experimenting with ways to create objects directly from digital designs. In 1984, American inventor Chuck Hull developed a process called stereolithography, often shortened to SLA. His machine used ultraviolet light to harden liquid resin layer by layer until a solid object formed. Hull later co-founded the company 3D Systems, which helped commercialize the technology. At first, 3D printing was mainly used for rapid prototyping. Companies could quickly create sample products without expensive molds or factory tooling. This saved both time and money. During the 1990s and early 2000s, improvements in software, materials, and machine accuracy allowed the technology to spread into industries like engineering, medicine, architecture, and aerospace manufacturing. Every 3D printed object starts as a digital design. Most designs are created using CAD software, which stands for Computer-Aided Design. Engineers, artists, and hobbyists use these programs to build detailed virtual models on a computer. Some objects are also made using 3D scanners, which capture the shape of real-world items and convert them into digital files. Once the design is complete, the file is exported into a format that the printer can understand, usually STL or OBJ. Specialized software then slices the model into hundreds or even thousands of thin horizontal layers. These layers act like instructions for the printer. The machine reads them one at a time and carefully recreates the object from the bottom upward using extremely precise movements. Although there are several types of 3D printers, most follow the same basic principle. The machine creates an object by adding material layer upon layer until the final shape is complete. One of the most common methods is FDM, or Fused Deposition Modeling. In this process, plastic filament is fed through a heated nozzle, melted, and deposited onto a build plate. The material cools quickly and hardens into shape. The printer then adds another layer on top of the previous one. This continues repeatedly until the object is finished. Resin printers work differently by using light to harden liquid resin, while industrial metal printers often use lasers to fuse metal powder. Despite their differences, all 3D printers rely on precise layering and digital instructions to build physical forms. The materials used in 3D printing depend on both the printer and the purpose of the object being made. Most consumer-level printers use plastics such as PLA and ABS. PLA is popular because it is easier to print and is partly made from renewable resources like cornstarch. ABS, on the other hand, is stronger, more durable, and better at handling heat. Resin printers use liquid photopolymer resin that hardens when exposed to ultraviolet light, allowing highly detailed prints. Industrial printers can work with materials like stainless steel, titanium, nylon, carbon fiber composites, ceramics, and even concrete for construction projects. Scientists have also experimented with food ingredients, recycled plastics, and living cells for medical research. Since each material reacts differently during printing, machines must carefully control temperature, speed, and cooling. The chosen material greatly affects the final product's strength, flexibility, appearance, and cost. 3D printing is now used in many industries around the world. Hospitals use it to create dental implants, prosthetic limbs, hearing aids, and surgical models that help doctors prepare for complex operations. Aerospace companies print lightweight parts for aircraft and spacecraft to improve fuel efficiency and reduce costs. Car manufacturers use the technology to build prototypes and test new designs much faster than traditional methods. Architects create miniature building models for planning and presentations, while schools use 3D printers to teach engineering and design concepts. Some construction companies can even print walls and small houses using concrete materials. During the COVID-19 pandemic, 3D printers also helped produce face shields, ventilator parts, and other medical supplies when many global supply chains could not keep up with the sudden demand for essential equipment. 3D printing changed manufacturing by turning digital designs into real objects through layered construction. What began as a tool for prototypes has become a global industry used in medicine, engineering, education, construction, and space exploration. Its ability to create customized products with less waste makes it valuable for modern manufacturing. Although challenges involving speed, cost, and material strength still exist, the technology continues to improve. Today, 3D printing allows people to design and produce complex objects almost anywhere using only a machine and a digital file. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.